Alright, so let's go through a transformation in full. And I'm going to do this in two ways. So at the beginning, I'm going to start with the parent function. The parent function is y equals x squared. Okay. And then I'm going to transform it with tables. And then I'm going to do another version that uses, we're just going to graph the first transformation by looking at it, and then we will do composition. So composition will come at the end. So we start with y equals x squared. F of x is a quadratic function just like x squared. It's just been stretched or compressed, or it has been shifted. All right, so I'm going to create a table that shows y equals x squared. Okay, so x squared is a function. So I'm starting with a list of x values where I know I'm going to get the vertex. So the vertex is that point at the bottom of a quadratic function, or the top if it's upside down, and it's the point where it stops decreasing and starts increasing. Okay, think of it like a roller coaster. That's the bottom of that, and I know that that point is at 0, 0 for the quadratic function y equals x squared. Okay, there hasn't been any shift. It starts at the origin right there. And so I'm just doing a couple points on either side. You know, I could do more. I really couldn't do less, but I could do more of these, but we'll just do these 5. So if you have -2 and you plug it in for x, you get 4. -2 squared. -1 squared, 1. 1 squared, also 1, and 2 squared, also 4. All right, and you see this, there's this pattern with quadratics where on either side of the vertex, the y values will be the same, because when you square a negative number, it becomes positive. All right, so that is the parent function, and it is always the same, okay, because these are all quadratics. They're all the same, come from the same parent function. Okay, just like you and one of your siblings may have some similar features, or have some different features. A lot of times you have some things in common, so that's why they call it a parent function. This function f of x will have the same features in that it will have the same shape, but it may look a little different, maybe a little taller, maybe a little shorter, maybe a little more left-leaning than the others. So what we're going to do is we have to make some transformations from these points, and so that's what we're going to do. We're going to make a new table, and the x values in your table are changed by adding h. Right? H is the horizontal shift, and that comes from the form of this. F of x is equal to a times x minus h squared plus k. So h is the number that's in the parentheses here. X minus h. So this number is h. Right? If it didn't say minus, if it said plus there, then the h value would be a negative number. Okay, this is the one that's opposite. So when I say add h, you got to know what h is. So we'll write a, h, and k down. H is a positive 4 here, always the opposite for the x value. And that's our horizontal shift. So if h is 4, that means I'm shifting all of these x values, I'm shifting them right 4. So 0, 0, that point is now going to be in this column where the 4 is. And so add 4, add 4, add 4. And if you write these numbers in order, they will still be in order. They'll just all be 4 bigger than they used to be. All right? For the y values, these values right here, we have to multiply by a, so times a, then we add k. Times a, add k. And so 4, we got to know what a is. A is 1/4, and k is -2. So I'll take 4 and I'll multiply it by 1/4, and I get 1. So let me erase this. Come on, eraser. I believe in you. There we go. All right, so I'm going to do times a fourth and then minus 2. So that one will be 1 minus 2, negative 1, times a fourth and then minus 2. And that one will be negative 7/4. And then this one times a fourth minus 2 is negative 2. Fourth minus 2 times a fourth minus 2. And these are going to be the same on either side. Alright, so now we can graph f of x, which is a transformation of the parent function x squared. It's going to be a little squattier, and it's going to have moved to the right 4 and down 2. Right? So the way we would describe this in words, we would say it has been compressed. You could say squished even by a factor of 1/4. Then it has been shifted right 4 and down 2. You always do your squish or your stretch first. And so I'll just start graphing those points. 2, negative 1. 3, negative 7/4. You could convert that to a decimal if you want, negative 1.75. Negative 4, 4, negative 2. Same point over here, over here. All right, if I wanted to, I could do more points, but it's going to look something like this. All right, so there's f of x. And now we can do g of x. We can do it in the same way, x, g of x, except x is, or g of x is not coming from the parent function. G of x is coming from f of x. Right? So in a roundabout way, it's coming from the parent function. But g of x, if we were looking right here, is twice f of x minus 2. Right? So f of x minus 2 times f of x minus 2. And so we're going to have a, h, and k values that come from that. And this is being written in the form g of x equals a times f of x minus h plus k. So what is the a value? It's the number in front of the f of x part. It's 2. What is h? It would be the number in there. There isn't one, so it's 0. And the last number there is negative 2. All right, so for our x values, we add h, but h is 0, so our x values actually don't change. It's very nice. Our y values, however, they do change, okay? And this is going to get a little messy. If you have a calculator, it's far less messy. We're going to have to multiply by a and then add k. So negative 1 times 2 is negative 2, minus 2, negative 4. Negative 7/4 times 2 minus 2. That's going to be negative 3.5 minus 2, negative 5.5. Negative 2 times a, which is 2, minus 2 will get us negative 6. And then it's going to be the same on this side. So we get new points. We got 2, negative 4, way down here. We got 3, negative 5.5, which would be about right here. We get 3, negative 6. This is what we call a formatting error. I did not leave enough space for this, and I apologize. I can't change the past. All I can do is vow to be a better person next time. Okay, so this thing's twice as tall, and it has been shifted down 2 units. But why not? So if it started here and we went down 2, why isn't it at negative 4? That's because we do the stretch first. So the first thing we did was we doubled this number. We moved it to negative 2 times 2 made us at negative 4, and then we moved it down 2. Okay, so you'll see that when things are stretched, there's a little bit of a different look to it. It's not, if it's moving just left and right and up and down, the shape stays the same. But our shape has changed, and you have to do your stretches first. All right, so there's that. I'm going to try to clear this whole thing. And we're going to redo number 4 this time This time we're going to do composition. So if you came for the composition, here we are. We have arrived. So the first thing you would do is you would graph f of x. So you would go -4, -2. That means I'm going to go to 4, -2. There's my vertex. And if you're a composition person, you're probably a person who knows this pattern, 1, 3, 5, 7. That means as we go away from the vertex, we would go up 1. The first time, when we go away 1 more, we'll go up 1, 2, 3. We would go up 3, go away 1 more, we go up 5. Well, this time we have a stretch factor, so we're going to multiply all these by a. And when we do that, we get 1/4, 3/4, 5/4, and 7/4. All right, so as we move away one spot, we only go up 1/4 of a cube, 1/4 of a block there. And then when we move away one more, we go up 1/4 to 3/4. Okay, 1/4 plus 3/4 gets me a whole 1 from the vertex to here. Okay. As we move away one more, we would go up 5/4. It's right here. 5/4. And as I go away one more, it would give me up 7/4. Okay, so if you do this version, you kind of get a fuller picture of what this quadratic looks like than what we had before. Okay, so there it is. That is f of x. I'll do that. That was blue. So now I'll make this one. Let's do this color. Do that deep purple, that plum color. Let's do that. G of x. Okay. So how is g of x related to f of x? Well, it's twice as much as f of x minus 2. F of x is still its own function, all right? And so when you see f of x, x is what you plug in for the variable, so nothing about this function changes. There's no horizontal shift. But what we do is we plug in f of x in this equation right there. Okay? So when I come to f of x, I'm going to replace it with this. So put it in parentheses because all of it needs to be multiplied by 2. 1/4 x minus 4 squared minus 2. Okay. And minus 2. Okay, so what do I do now? Well, now all of this is being multiplied together. So I need to distribute the 2 here, and I need to distribute the 2 out here. So I get g of x is equal to 2 times 1/4 is 1/2. X minus 4 squared. 2 times -2 is -4. And then this minus 2 just comes back down here. Right? Last step, we're going to combine it all. 1/4 x minus 4 squared minus 6. Okay, so our vertex is at 4, -6, just like it was last time. Craziness. And then our pattern, 1, 3, 5, 7. So just the same way we did f of x, we can do g of x, but we multiply them all by 1/2. Times 1/2, times 1/2, times 1/2. So I get 1/2 here, 1.5, I get 2.5, and 3.5. All right, so as we move away from the vertex, the first time we go up 1/2 of a block. The next time we go up 1.5, right here. The next time we would go up 1, 2.5, 2.5. The next time we would go up 1, 2, 3.5. It'd be right here. And it looks like that. Okay. And that is composition. We'll do another one, number 5.